Okay, ladies and gentlemen, tonight I'm going to talk about the New Horizons mission to the Kuiper Belt. Uh, about oh, 1989, after Voyager 2 went by Neptune on its way to the outer solar system, uh, Dr. Alan Stern and some other astronomers said, well, we have flown by all the outer planets, and we've also looked at the inner planets. What's left is Pluto. We ought to have a mission to Pluto. So around that time, 1989 or so, they started working on proposals. They sent to NASA. They started doing some politicking. Uh, they really did work at conferences, scientific conferences, and got a wellspring of interest in doing this. And finally, in 2002, NASA approved the New Horizons mission. They called it the first of their New Frontiers missions. These are major missions, sort of like the Voyager missions, the Galileo mission, and the Cassini mission. They tend to be long missions. They tend to be about $1 billion each. And New Horizons was approved on that basis. The purpose of the mission was to do a flyby of Pluto and Charon's system with imaging and spectroscopy in the visible, ultraviolet, and infrared. Some particle analysis, electrons, protons, and a radio science experiment. And then if everything worked out really well, they hoped to fly by another Kuiper Belt object, if possible, with similar science objectives as the Pluto and Charon system. So on that basis, it was launched in January of 2006, the same year that Pluto was demoted from a planet to a dwarf planet, one of the objects in the Kuiper Belt. So you say, what is the Kuiper Belt? We'll look at it in a minute, but it's a donut-shaped cloud of hundreds of thousands to millions of objects orbiting the sun beyond the orbit of Neptune. Dwarf planet Pluto was the first Kuiper Belt object found back in 1930, and it's still one of the largest Kuiper Belt objects. Some of the highlights are, I hope you're hearing this better than I. It's horrible in my earphones. It was launched in January of 2006 on an Atlas V rocket with 5 solid fuel boosters plus 2 additional rocket stages. And that was able to let it achieve the highest launch speed of any spacecraft yet flown. A gravity assist maneuver at Jupiter decreased the travel time almost 4 years and provided instrument checkout and science information. And we're going to look at a little bit about that in just a minute. Like the Voyagers and Cassini, a radioisotope thermoelectric generator, or an RTG, was used for power. When you're out in the outer solar system, you're too far from the sun for solar cells. They won't work. So you use a radioisotope, usually plutonium metal, which is very hot. You put some wires to it of dissimilar metals. That forms what's called a thermocouple. And with the other end of the wires is cold, like outer space, an electric current will flow down the wire from the hot plutonium to the cold electronics inside the spacecraft. So the RTGs are used on Voyager, they were used on Cassini, and they're used on New Horizons. There's a picture of the New Horizons spacecraft. Up here at the top is the high gain antenna that sends data back to Earth. This must be one of the telescopes with spectroscopy, etc., inside that it uses. And this is the RTG. You'll notice the heat radiating fins on it. It's radioactive inside here, that's the plutonium. So you want to get the heat and the radiation away from all the electronics in here. So that's why it's outboard. And so this is what they sent. This is the New Horizons spacecraft shortly before launch. Now here is the outer solar system. Here's the orbit of Neptune, Uranus, Saturn, Jupiter, and you really can't see the inner solar system. This, of course, in yellow is the orbit of Pluto, and right away you see a hint for why it's really a Kuiper belt object and not part of the solar system, not a planet, because you'll notice the other 8 planets are all pretty much in the same plane. Pluto's orbit is tilted quite a bit with respect to the plane. And in fact, during part of its orbit, it flies inside of Neptune, but most of the time, most of the 248 years period of its orbit, it's well outside Neptune. And here is a depiction of those hundreds of thousands or more small objects out beyond Neptune called the Kuiper belt. So for New Horizons, it was launched in January 2006 from Earth, went past Jupiter about a year later. In July of 2015, it went by Pluto, took pictures, and kept going. And we'll be talking about the keeping going in just a minute. Here's the Atlas V Centaur rocket with the New Horizons on top. This is the Atlas V. You're seeing 3 of the 5 solid fuel boosters. Here are the 2 Centaur stages. And way up here on top, hidden under the conical fairing, is the New Horizons spacecraft, right up in there. Let's talk about the Jupiter encounter, early 2007. These are the Galilean moons of Jupiter. This is Jupiter. Here's Io, Europa. Very interesting for possibility of life. We're pretty sure it has a ocean underneath the ice. Ganymede, the largest moon in the solar system, and Callisto. We won't worry about this little bitty moon that's in very close. Here's the path of New Horizons as it went past. I told you it went past. It got a gravity assist here. Okay. And while it was in here, it took a really good picture of a volcano on Io erupting. There's more volcanic activity on Io than there is on Earth. Closest approach was February 28, 2007, about 1.4 million miles away. And we're going to take a look at this picture in just a minute. But here is what I want you to see. Here's the story of gravity assist and how it works. This is the beginning of February of 2007 to May, 1st of May. New Horizons, this is the speed over here. You'll notice it was slowly slowing down. Why was it slowing down? Because of Earth's gravity. Gravity was trying to accelerate it back to the sun. So it was slowing down. It was being deaccelerated because of gravity from the sun. But then, along in here, it got close enough to Jupiter to start being grabbed by Jupiter's gravity, which accelerated toward Jupiter. coming in from the rear. So he gets sped up by the gravity of Jupiter, faster and faster, crosses right by Jupiter, and then starts leaving Jupiter up here. Now, Jupiter's gravity is pulling it back. But it doesn't last very long, and don't forget, it's going faster here than it was here. So the net effect is the speed has been increased. It's called a gravity assist. It sped it up, so it got out to Pluto faster. But then out here, Sun's gravity is still working, and it's still slowing down a little bit due to this gravity of the Sun. And this will get flatter and flatter the further away it goes. So I hope that helps you understand what gravity assist is all about. The net result is it sped it up. And by the way, you'll notice it also changed the direction. Now, I want you just to imagine how accurate those guys had to be to time the departure of this from Earth. So it went right here at the right time and at the right speed and at the right distance for the gravity, so that it would be bent the right amount, so as it then goes in a straight line, it will intercept Pluto in Pluto's orbit in 8 years. Think about that calculation just a little bit, and you will appreciate what rocket scientists can do. Here's what it got when it went by Jupiter. This is the moon Io. This is a visible picture, and this is a volcano previously seen. It's called Star. It's erupting. They estimate that the height of the plume was about 200 miles above Io. Here's another record visible light picture. You'll notice that Io is yellowish. These are sulfur compounds that many volcanoes erupt. You're probably used to that. And so when seen full face, Io looks yellowish with black dots on it where the volcanoes are. This is an infrared picture. You know what infrared is? It's heat. And sure enough, there is that hot volcano, Star. But look, there are some other hot spots, volcanoes to be or volcanoes that have just erupted. Io is very volcanic. And New Horizons was able to get some really neat pictures of this as it was flying by on its gravity assist. 8 years later, it reached Pluto. This is the famous picture you've all seen. You'll notice the rust-colored surface, very complicated. This became quickly known as the heart. Looks like a heart. But this is the full picture. Now here is the International Astronomical Union names for the terrain that were suggested by the New Horizons team. This big area is called Tombaugh Regio. That's named after Clyde Tombaugh, the guy who discovered Pluto in 1930. So I think this means Tombaugh region. This area, very interesting up here, is called Sputnik Planitia. It is now, this is essentially a lake of nitrogen ice, frozen nitrogen. And I've seen some speculation that this was an impact crater that filled with nitrogen and froze. And you can almost see the crater shape. Now this is a different kind of terrain over here and down here. There are some mountains. These are mountains down in this area. Of course, you know what Hillary Moss were named after. And his guy Tenzing, you'll remember that, for Everest. We're going to talk about that a little bit. And we're going to take a look at the Tartarus Dorsa region. This is some very interesting topography over here. So we'll just take some pictures of horizons got of the surface. Of course, this is the corner of the heart. This would be Sputnik Planitia here. This is frozen nitrogen ice. This is some water ice mountains on top of nitrogen ice. There's Hillary Mountains, or Montes, up in this area. There's our friend Sputnik Planitia, Planitia, whatever it's called. And here's Norgay Montes. And don't forget, this is water ice mountains lying on top of the nitrogen ice. Over in that Tartarus dorsa, they call this bladed terrain, and they say this is all spires of methane ice, hydrocarbon ice, about 1,200 feet high. So what you're looking at is very interesting and unusual terrain. Lots and lots of surprises when we got to Pluto. Everyone thought it'd be sort of like the moon or an asteroid or something, just a blah thing. No. Big surprises. Pluto is very interesting. Still in the Tartarus dorsa region, here is a fissure in the water ice terrain here. Up north of Sputnik Planitia, they found this pond of frozen nitrogen. It's only about 20 miles wide. And I think this is some water ice hills around it. Here's some more water ice hills on nitrogen ice glaciers. Here are the hills here. And this is the nitrogen ice that they're in the middle of. And this is a layout to show you where this picture was in Tomball ratio, you might call it the heart. Here we are in that southeast corner of Sputnik Planitia. Notice that rust color. This, unlike the Mars, where a lot of that is in fact iron oxide, these are chemicals, and I'm reading now they think a lot of this, and I showed you orange colors earlier, are what they call tholins. These are molecules that are created from methane and carbon monoxide in the presence of ultraviolet light from the sun. It causes a chemical reaction to produce tholin compounds, which are this reddish color. This is not iron. And this is some of the nitrogen ice sea, and you'll notice the pits and what have you. And here's a context for that. This was over in the southeast corner of Tomball Regio. This is the same picture you just saw. Here we're just looking down on the broad expanse of nitrogen ice in Sputnik Planitia. And notice these little pits. It's full of these little pits. It's also got some hexagonal texture to it. We'll see a little bit of that in a minute. Some question as to what these are. This may be sublimation of gases causing these pits in the nitrogen ice. I'm presuming this is blowing all your minds because you're probably having trouble thinking of nitrogen ice. You may have seen liquid nitrogen in the doctor's office or something, or welding, but nitrogen ice is really, really cold. Now here's some of that cellular design I showed you, the hexagonal in the nitrogen ice. This is a shore of that, and these are water ice mountains butting up against that large plain of Sputnik Planitia. But you see a lot of this terrain in Sputnik Planitia. Here's a northern thing, mainly nitrogen and methane ices up here, and it looks like some of those tholins may be here too. Notice the reddish, rustish color there. So this is just the northern hemisphere, if you will, of Pluto. Wide-angle picture. And finally, they got the sun behind Pluto and got this picture of this is the atmosphere of Pluto. And if you look at it carefully, you'll notice it's layered. You can see different layers in that atmosphere. Like I say, things are complicated on Pluto, much more so than anyone thought when we left back in 2006. Lots of surprises. Are you ready for Charon? Here's Pluto's moon, Charon. It's a pretty big moon compared to Pluto, very nearly the same size. Notice what's on top. The northern cap has that rusty stuff. They still think it's Tholins. There's no atmosphere on Charon. So where did the stuff come from? How did it get from Pluto over here? Still a mystery. And then there's this big canyon girding Charon. Another big surprise. Here's a close-up of that canyon. They think it was caused by water ice expansion. But take a look at the topography here. Here's the bottom of the canyon. Notice that this is about 7 miles higher than this. And have you been to Grand Canyon? It's not 7 miles deep. Now, in 2005, the Hubble Space Telescope people discovered 2 more moons. Here's the surface of Charon. These guys are very small, but the Hubble telescope in 2005 found Nix and Hydra. Nice little surprise, just a year before New Horizons left. And then in 2011, New Horizons is approaching Pluto. They discovered 6, a very small moon. And then in 2012, they found Kerberos, a tiny moon of Pluto. So it's got 5 moons, Charon, plus these 4 small guys. And don't forget, a lot of these guys were found while New Horizons was en route to Pluto. Interesting, huh? Okay, now here you're seeing Pluto, Charon, and those other 4 little moons. Let's see how they operate. Now, Charon and Pluto revolve around each other just like the Moon and Earth do. Since they're more near the same size, the rotation around their common center of gravity is more obvious. Notice the speed of rotation of these guys. Notice also the direction of rotation of these. Counterclockwise, counterclockwise, counterclockwise. Oh! Clockwise. They don't all rotate in the same direction. Those things in the solar system rotate and revolve counterclockwise like these two. And there's a reason for that, but we're not going to go into it. So the new science of Pluto is that it has been very geologically active over its 4.5 billion year history, and as recently as 10 million years ago. That bedrock is water ice, but it has surface ice coverings of nitrogen ice, methane ice, and carbon monoxide ice. It has an atmosphere of nitrogen, methane, carbon monoxide, and it's colder than expected, so that the gases are not escaping at as rapid a rate as they thought they were when the mission took off. And we didn't look at them too much, but there are some big ice volcanoes on Pluto as well. On Charon, we can say now that it's composed of water ice, no volatile ices, no methane ice, no nitrogen ice. It has no atmosphere. It has extensive geologic activity dating back to 4 billion years ago. It has an equatorial canyon that's bigger than Grand Canyon, but smaller than Valles Marineris on Mars, which is really a huge, huge canyon. Subject for another talk. And then they've got that mysterious red cap substance at the North Pole, now believed to be pollens, organic compounds that are produced by methane and carbon monoxide in the presence of ultraviolet light. Okay, after Pluto, you're seeing the inner solar system. The trip, we went by Jupiter, got the gravity assist, went by Pluto, right here. Last New Year's Day, we wound up at a little Kuiper belt object. Its name was 2014 MU69, and they found it in 2014, just a year before they got to Pluto, and decided that they could, it was within range of their fuel system. So they aimed for MU69, here it is, and in that period of time, they've been finding other Kuiper belt objects. But this is the one that was close to the trajectory and that they visited, flew by, last New Year's Day. There it is. These are the pictures. You'll notice that same rust color. That seems to be a characteristic of Kuiper belt objects. But it's not what it looks like, and I'll show you that in a minute. About a month ago, the New Horizons team had recommended to the International Astronomical Union that this object be named the Indian name Arakoth, and it was adopted last month on the 12th. This is a Powhatan Algonquin Indian name. They are peoples that lived in Virginia and Maryland. The Johns Hopkins University and the Applied Physics Laboratory, which is where New Horizons was run out of, is in Baltimore, Maryland. So all taken together, they thought this was a very appropriate name. And as of a month ago, this object is now known as Arakoth. But very clever. As they were going by, they looked at the shadow of Arakoth against the background of stars. And they looked very carefully at when its shadow extinguished stars that were in the background. That's called an occultation. And they discovered by analyzing that very carefully, as only rocket scientists could do, that this is the actual shape. These are not spheres like they appeared to be in that frontal picture, but we've got a flat-shaped rock and a fatter-shaped rock, and they have just gravitationally come together gently and are kind of stuck together by gravity. But in any event, this is what we are actually believe that Arakoth looks like, up close and personal. I'll give you a quick little view of it if the internet will provide it for us. Not sure we have a fast enough internet today. It's very quick. That's what they got. Did you enjoy that? Okay, let me get back down here. I'll do it this way. And finally, let's see where it is today. This is another one of those nice, whoops, didn't do it right. Let me go back, try to do that right. If you'll notice down here, it says 15th December. That's tomorrow, isn't it? But look, it's midnight Universal Coordinated Time. So this is a few hours from now. But this is now Universal Time. There's where it is right now. This is where Arrokoth was, or is right now. You know, it's been moving along in its orbit. Pluto's been moving in its orbit since we went by there, and Jupiter's back here. Went by all of them. So that's the latest on that. Okay, let me back out of here. I presume you're seeing all this stuff. Not much more to go. So New Horizons seems to have enough fuel and RTG power to make yet another KBO flyby in the next few years. It's traveling about 1 billion miles every 4 years now. And during this summer, 2020 and 2021, the largest Earth space telescopes and the Hubble will be searching for candidates along the New Horizons trajectory that it can reach with the fuel that it has and make one more discovery of a Kuiper-built object similar, presumably, to Arrokoth. All right. I sure hope you've enjoyed this.